The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to today's webinar on valve stem seals. I am Amanda Harmoning, and I will be moderating today's event. And joining me, I have Rob Monroe and Chuck Lynch.
Morning, everyone. Rob Monroe here. I want to welcome everybody. I look after membership and technical development with AERA, and look forward to answering some questions that you may have. Amanda and I will be in the background. If you have any questions, she's going to show you how to fill out that questions box, and look forward to today's presentation. Hey, Chuck.
All right, good day, everyone, wherever you may be. Chuck Lynch. I'm a tech specialist here at AERA, and I also do custom training on site, and we're glad to have you all with us.
All right, thanks, guys. Before I hand things over for the main presentation, I'm just going to go over a couple housekeeping slides with you. First off, there are a couple different ways you can listen in to today's presentation. The first is to dial in via phone, and if you do that, make sure you select that radial button for telephone and enter your access PIN and audio code. The second way is the mic and speakers, and again, just make sure you have the appropriate button selected. This will allow us to make sure all lines are muted during the presentation. A couple other items. The first one is the grab tab. This is the little reddish orange box with the arrow in it. If you collapse this, it'll move that control panel out of the way for you during the presentation, and you can open it back up if you have to ask questions or adjust any of your settings. And the last item is the questions box. If at any point you have questions, comments, anything for us, go ahead and type it in that box, and Rob and I will be in the background answering those questions. So at this time, I'm going to hand things over to Rob and let him move forward with the next part of the presentation.
Super. Thanks, Amanda. Just while Chuck's getting set up here, for those of you that are not members of AERA or you don't know who we are, we've been around since July 1st of 1922, so we've been around a very long time. We have members that are engine professionals and include builders and rebuilders, installers, parts and supply manufacturers, as well as distributors, manufacturers reps. We have schools that are members, government agencies that are members, over 2,000 members worldwide. Now, kind of just like this slide says here, AERA, we really promote the ability to network. Kind of like this opportunity today with this webinar, it is a form of networking. We're going to learn some stuff from Chuck, as well as some of our tech and skills conferences that we have, or any of the opportunities that we have to get together as a group. We learn from each other. And that's the whole idea of what we're doing here at AERA, is we want to create these opportunities to get you together so that we can all learn and help move this industry forward. For those of you that aren't members, just a quick little recap here of what's included in your member benefit package. We've got the specification manuals. There's 7 of them. For those of you that are members, you should have just received the 2. We got brand new connecting rod manual as well as a crankshaft manual, and those are in the mail now, and you should have those. We've got our Engine Professional magazine. It gives you unlimited access to the toll-free tech line. We've got our automotive machining online training program. So AERA has an engine machinist certification program that we do offer. We've got our contingency connection rewards booklet when you're a member. That's loaded with all kinds of discount opportunities. We've got our special discounts from our AERA corporate partners. Our process software, specification software, again, can help save you time within the shop. And we've also got our custom training program. This is a newer program that we offer, and Chuck looks after this program. He can come to your shop, help you with things like equipment setup, training an employee, things with quality control. He can help you develop processes within the shop to help save you time and make some money as well. Something else too is we've got in our tech center, this is an unlimited use as a member, and we are open from 7 a.m. to 6 p.m. Monday through Friday. And we encourage everybody to call the tech center. Let us do all of that lookup for you. You're better off in the shop sort of making money, running those pieces of equipment. Let us do all that research and homework for you. There's 5 techs right now that are on the tech line. We've got Dave Hagan, Steve Fox, Chuck Lynch, Brian Roberts, and myself. and we can answer any of the questions that you have. And go ahead, you can call our tech line, you can email our tech line, or you can fax our tech line. So each one of us has a particular specialty that we're very good at, but any one of us can answer any questions that you do have. Want to remind you that on March 2nd in Memphis, Tennessee, we've got the CompCams Tech and Skills Conference. And CompCams is hosting this particular conference. It's going to be on that March 2nd. We've got all kinds of good technical presentations available for that conference. Chuck Lynch, again, will be speaking. He'll be talking on valve seat machining. Lake Speed Jr. will be there doing some presentations on what you should know about oil. Ron Sledge from King Engine Bearing, he's going to be talking about coated engine bearings. Billy Godbold from CompCams, he's going to speak on surface engineering for performance and durability. And then lastly, we'll have Keith Jones from Total Seal Piston Rings. He's going to talk on modern piston rings and what has changed and why. So again, great opportunity to network. There's lunch involved. CompCams will be supplying lunch. Any of you, those that are members of AERA and you're going to attend this Tech and Skills Conference, keep in mind that we will provide you with a $50 reimbursement through our Engine Rebuilders Educational Foundation program. So after attending, you will get a $50 shop reimbursement for attending. Lastly, before we bring Chuck on, just a quick reminder for those of you that aren't members, it's relatively inexpensive to be a member, and it's well worth your money and dues to be a member. Again, just the amount of time that it saves you in the shop with not having to look up and go online and find your specs, we can do all of that for you, and we encourage you to give us a call and let us do that for you. So by the time you put your $75 contingency connection coupon in there, you're only paying $324 for the year for membership for a typical U.S. active member shop. So we really do encourage you to have a look at that. So right now, I'm going to move over to Chuck, and Chuck is, like I mentioned, is one of our tech specialists here at AERA, and I'm looking forward to the presentation. And if you have any questions about membership or about Chuck's presentation or anything, Amanda and I are in the background. We'll also leave a little time at the end too so that we can get those questions answered for you. So afternoon, Chuck, how's it going?
Going great, Rob. Again, hello everyone. I can see that several people have joined since we first started. Today I'm going to be covering valve stem seal designs, materials, and testing. I have a pretty good amount of information compiled here, and I can speak from what is documented knowledge and a lot of practical knowledge over the years. Valve stem seals are something that sometimes they're overlooked as how complex they truly are. It's kind of like a lifter. There's really a lot going on there. So first we'll start with a bit of history. Until recently, valve stem seals were really, they weren't a seal, but they were more of a shedder, a pretty crude device. So they didn't seal anything. They were just deflecting it. And the evolution of engines, emissions and things of that nature would have driven us to much more complex components. Umbrellas or shedders varied in seal materials over the years. Some of the materials are as follows. Silicone, actually many of the early reproduction seals have switched to silicone. It's pretty inert to a lot of the environmental conditions, the oil attack and fuels and things of that nature. Nylon, the nylon were the ones that actually kind of snapped, good example, like early 466 International, they had a nylon. Some of the Cadillacs, the old Cadillacs, they had a thing that popped into the valve retainer. Nitrile, polyacrylate, some of those seal materials were even used for crankshaft seals. And more commonly now are the fluoroelastomers. There's many of the even umbrellas that someone has decided, hey, since these fluoroelastomers are very durable, can stand up to high temp, low temp, and many chemicals, we'll just convert those into these newer classifications or materials. So as we talk about valve stem seals improving, transitioning from 70s into 80s, a very common seal that was used was a stationary seal, which was pressed over the guide, and that was often referred to as a positive placement seal. If you take a look at those images there, I'm sure everyone is pretty familiar with that design. That design was even coined the perfect circle seal, even though there were many other manufacturers that were making that. That's actually, they would see the PC with the circle around it. It's actually a registered trademark deal. But any of the other, aftermarkets that were even making that particular design, people would say, oh, that's a perfect circle seal, no matter who the manufacturer was. So, some name recognition that really kind of stuck. Now, if you talk to a competitor's engineering staff, a lot of times they would refer to the nomenclature of it being a ring and band seal. So you can kind of look for both of those things if you're trying to find a particular product. Now, spring forward to the current commonly used seals, is this metal clad top hat style seal. We refer to it as a top hat because, quite honestly, that's what it looks like. These seals are actually quite impressive by all of the functions that they actually provide us. You can see there, not only is it controlling the volume of oil that enters the valve guide, they can properly center the spring around the valve guide OD, and then they're in aluminum castings in particular, that also provide you a hardened wear surface so that the valve spring doesn't chew a hole through a cylinder head. And I can tell you, it really doesn't take all that long if you were to forget to put a shim under a valve spring on an aluminum head that would bore a hole through the head. With that rotation and that one sharp edge that's on the valve spring where it's ground, it happens pretty rapidly. So, controlling factors for performance of valve stem seals. The success of a stem seal is reliant upon several physical environmental conditions that we have to control in the machine shop. We must ensure that we provide the seal with the opportunity to function properly, and then that some of the following bullet points, I got an additional couple of slides here, highlight some of the key mechanical factors in the machine shop that you control, and then we'll move into how the seals are designed and some of the parameters there. So guide OD must be the correct diameter. That was actually an issue with the earlier ring and band type seals, was the guide ODs. There was a lot of variation in casting, and so they could, the ring and band was fairly flexible, but there's distortion because of spreading that material so far. It's so some of those guide tolerances, they may have had 25, 30 thousandths variation, where most of the guys now, you're talking a maximum of about 2 thousandths on diameter, but typically they're going to be a mean diameter plus or minus a half a thou. So we've really come a long way in controlling that. The guide OD must have the correct surface roughness. Now with the top hat style, the roughness is definitely much lower. You're going to see numbers of 30 RA or less. Powdered metal guides, you're talking single digits. But in the past, if you had a positive displacement or a positive position seal and the guide was too smooth, actually just the friction of the reciprocation of the valve stem would actually pull the seal off the guide. So that did also become a concern. So interference being proper and surface finish, but now the late model stuff is very smooth. The guide OD, this is a super critical parameter here, must be concentric within a couple thousandths of the center line of the guide. So is some flexibility in most of the seals, but if you get that center line off, then, you know, and they're fairly high interference against the stem anyway. But if you get that center line off, well, oftentimes you'll have an elliptical shaped valve stem seal opening, and it's a perfect opportunity to pump oil. You have one side that's got a lot of friction against the stem, the other side is loose, and they can work about like a bellows pump. So you would probably be better off if you had no seal there whatsoever than being in that position. And upcoming in a slide, I'll have a good illustration of this. The guide must be installed or machined to the correct height to ensure proper installation. Top hat style seals, some are an element that's put into a steel body. Some of those are molded together. They are more sensitive to the guide height position than, say, an umbrella or, you know, any other positive seal that would be pressed on the guide. You know, you have to make sure you got clearance between the retainer and the top of the guide and things of that nature. But if the guide is too tall on a top hat style seal, you can actually deform the rubber element on the inside. You can push the sealing element out, or just shear the material if it's bonded to the steel. You can have situations where oil can migrate under the guide and then still be sucked down into the combustion area. And again, as I was speaking to earlier, or you can just shear the material by having a guide that is too tall. The guides should not be cracked. Again, risk of oil passing around or under the valve stem seal. That can be a condition like you have a integral guide head and you drill out and put repair guides in. And if you have cracks in that parent body, there's still opportunity for that seal to allow oil migration up and over and then into the combustion chamber. Valve stems, again, we're stepping away from the seal a little bit, but it still has impact on the performance of the seal. So, you know, if we're reclaiming valves, and even new, you know, shipping and handling and things of that nature, valve stems should not have nicks or scratches that are going to travel through that seal lip area and potentially damage the seal lip or, you know, create a direct leak path. Valve stems should not have an aggressive surface finish. Typically 16RA is an accepted maximum roughness for, you know, valve stems in this day and age. So 16 or lower for positive position stem seals. Shed or O-rings can be higher. I would probably venture to say most of your valve manufacturers are not going to say, well, we're still going to make this 1971 Oldsmobile that only had an umbrella seal on it. We're going to make it at a 32 RA max, or, you know, somewhere about 24. By and large, everybody's going to say it's easier to just grind them all to this particular surface roughness specification, and that's what we'll yield. But again, those other seal types are going to be more tolerant of a higher roughness on this valve stem. So here's, again, looking at some of the constraints of the valve seal design. If you take a look at on the right-hand side, that kind of blown up area, it's what I was talking about. The height of the guide can be very critical. That inside element has force not only on the side of the guide, but on the top underneath of the garter spring there. So if that guide is too high, the amount of the distortion can be, you know, very damaging to the seal. And even if it doesn't tear material, you're going to change the shape. So the effectiveness of controlling oil flow into the guide is going to be affected by that. Here is kind of an illustration in an upcoming slide. There's going to be a little bit of a animation. So at the seal design level, information is gathered regarding the engine conditions, Engine application will influence the seal material. Lip design, the forces applied at the sealing lip. So this is done at the, finite element analysis point of the design. So much like you would do FEAs for, fasteners for head lift, or, what's going to be happening to a piston, what's going to be happening with a valve, these same types of analysis are done in development of the valve stem seal. Engine factors that can be included but may not be limited to the seal design. Of course, fuel type, oil type, you like propane, natural gas applications, you're not going to use the same oil that you're going to use in a diesel, which is not going to be the same that you're going to use in your gasoline passenger car. There is some crossover. If you have a multi-fuel engine, maybe you've got a CNG application, and you run gas when you have it, and you run, or gasoline, and you switch back and forth, you're going to use some multi-grade oils there. One time I remember a Federal Mogul engineer that designed crankshaft seals talking about, with all the oil changes, basically every year there's new changes. That's why they just try to throw the highest level materials at it. So, they're not dealing with, well, this oil supply has got this additive pack and this is this additive pack. So they just kind of, they try to go for the highest level. But, oil does have a huge impact on the effectiveness of any material used for a seal. The desired oil flow rate entering the guide. So there's actually some, specifications that are driven down to the engine manufacturers on the amount of oil that's allowed to enter the combustion chamber via the valve guides. There's about 5 classifications right now. The higher the number, the lower the leakage rate. So, that's really important. Max power rating. Is this thing a constant RPM like a generator, or is it a varied RPM? That's going to affect your, the vacuum signal seen at the valve and ultimately on the valve stem seal. Max number of RPMs, the number of cylinders, manifold pressures and vacuum, and then valve train geometry. If you have something that's an inline, overhead cam, a V engine, those things are all going to impact the amount of oil that is standing around the stem seal. With overhead cam engines, that's as much of an issue as anything. You may have an engine that's got the valve stem seals submerged in oil constantly. So then, the flow rate that you're going to allow is going to really be put to a test when you're totally submerged in oil all the time. Seal lip designs can vary from single lip, which is, probably the most common. You have multi-lip and annular groove. Multi-lip and annular groove can be very difficult to discern. So you have to be really careful. Say if you're going to qualify a seal, a good example would be series Cummins. So say an over-the-road application may have a different lead in that annular groove than a marine application. And then sometimes you have a situation where it's a kind of a hybrid. I've seen where on like some of the stationary power, like the exhaust would use the marine seal and the intake would use the automotive seal. But that lead angle, you would see like a high helix or a real low helix. And again, sometimes they're just multiple grooves. That picture kind of to the left there, I can't really say whether that's a annular groove or a multi-lip. But again, if you don't cross-section the seal and try to follow that pattern, it can be really difficult to tell. Here's just a little illustration of some FBA that was shared with me. This will help kind of, put some illustration to that about, if guide height's too high, if you have too much interference on the guide. And, something else we'll get further into is, with our industry of rebuilding and remanufacturing, we tend to do things like oversized stems and whatnot. So those are definitely things you want to consider. So qualifying valve stem seals after the design phase happens by running on test rigs. The rigs are specifically designed for reciprocating seal testing. So, crank seals, round rotational seals, definitely much easier for the general public to come on. You can kind of come up with your own test, and a lot of people do spin testing and so forth, but valve stem seals is pretty tough. To take the amount of time if you were to put an engine on maybe a spintron, a spin test, or whatever that rig may be, it's sometimes hard to establish all of the parameters around vacuum and pressure against the port and things of that nature. So this is definitely not an easy to reproduce piece of equipment. So this is kind of a cross section of what it looks like within that machine. So the test rigs will have the customer's guide, and typically this stuff is at the OE level, but some of the reman facilities are having to do this to, okay, a good example, one that I personally was involved in was like a 3126 cat, and they actually have two different groove depths on the ID of the guide. And then you start playing around with oversized stems, and then, okay, so you change the groove depth, and then you impact the stem seal itself. So this rig will actually operate the valve that the customer wants to use. They'll cut the head of the valve off, and they'll grind it to a point. They'll use the actual springs, retainers, valve stem seals that you intend to use. They want to build the manifold that receives the guide with the actual OE guide, and then you would, the customer would machine it to whatever specifications and tolerances they want. And then underneath of the valve, there's going to be a cup there, and they're going to capture the oil over a period of time and say, okay, does this meet the classification that's going to be required for this platform of engine? There are some SAE papers written about this. Metered leakage prediction for reciprocating valve stem seals is available, and design and life performance of valve stem seals are a couple that I actually have copies of that, they get into a lot of the deep math about, these parameters that are, being discussed in class 1, class 2, class 3 through 5 on the valve seal leakage. So the test simulates the valve stem seal in actual engine conditions. Measurement of the oil metering rate is at 1/10 milligram per hour. Engine speed, these rigs will run, as you can see, from 200 to 4,000 RPM. Oil temperatures, they'll take them up to approximately 250 F. Port pressure or vacuum is applied as specified by the design criteria. And then, it establishes a reference point based on that metering rate classification again. Here's some examples of, the test rigs. You can see some iteration changes over time. Some are more of like the just a single inline engine, and then some can be set up to represent a V, um, based on, again, engine application. You may even have some variation from one bank to the next on, vacuum signal, the way the intake manifold's designed. Ideally, you want everything to be exactly the same, but anybody that's ever built and tested engines and had them on the dyno, that there are certain ports that breathe differently than others. So, you may have to equate some of that stuff into these factors. As I was speaking to earlier, areas of caution, and in the rebuild industry, we have to be creative when we're trying to salvage castings and be cost competitive. So, things to be cautious of: oversizing valve stem diameters. In years past, we used to do things like there were stems that were 15 and 30 over. When we had 30 over stems, pretty much everything was an umbrella with an O-ring. Start undersizing stems. Again, that's going to impact the load being applied at the stem interface. There are some rough numbers. A lot of the stem seals, they can have 40 thousandths interference on a garter spring single lip style. So, but you just can't take that number and say, I'm going to use that across the board everything. Maybe that ring and band design, which could also be inserted into a top hat, maybe it doesn't like that. So, you just have to be really cautious about that. If you're in the capacity that you do a lot of volume and it makes sense to try to do an oversized stem, then you should probably consult a manufacturer about maybe performing the test for you. That can be done at a cost. You can just, you can contract some seal manufacturers to perform this test, and you could use all the OE parts as a baseline, and then switch it up and have your oversized stems and oversized seals, or the standard size seal or whatever, and you can get some results that can prove or disprove whether your project may work. The use of alternate application seals, because it fits. Been there, done that, been successful, been unsuccessful. Just because this seal is fits a 8mm stem, well, I'm going to stick it in this application, it should work just fine. Well, maybe that lip design was designed for a push rod engine, and you're trying to use an overhead cam engine. Again, as I said earlier, if that thing is standing in oil or completely submerged in oil, then the results can be drastically different, even though, hey, same stem diameter, it should work. So just keep those things in mind. Be cautious. Materials are mostly fluoroelastomer now. Using alternative materials may not survive in your particular environmental condition. There's a lot of importing going on worldwide. So maybe somebody doesn't have the knowledge to say, hey, this particular engine is going to have oil temperatures that often do see 230 degrees. It's turbocharged, direct injected. So we have to be cautious about that and validate the materials that we're going to use, or you're probably going to have some short-term failures. Polyacrylate and butyl and nitrile and so forth. Those started out as crankshaft seals. You don't see too much of that being utilized anymore. So valve stem seal failure modes. So the short answer, everything is going to kind of a little bit relate back to oil consumption. Oil consumption in late model engines is somewhat hidden by catalytic converters. I'm sure there's some of the folks that are on this call right now that can attest to, people complaining about oil consumption, but they cannot see it out the pipe. you know, catalytic converters are really hot, and you can burn the oil, so you don't have your telltale sign of smoke. And you know, we're all guilty of it as vehicles keep providing you greater comfort and, you know, extended intervals on servicing. You know, people don't, every time they stop for gas, they don't pull the dipstick and look where the oil level is. So, you know, and the lights, they usually don't come on until things are in pretty dire shape. You know, you got the 6-quart oil capacity, and the light comes on when you're at 1.5 quarts. So, you know, how long have you been aerating oil or starving, you know, bearings for lubrication? So, you know, you can have rod and main failures because valve stem seals were the wrong application. They were defective. You had oversized stems that, you know, made them work like a bellows pump. And this is something that's actually being talked about a bit more now, not necessarily because of valve stem seals, but the direct injected gas engines. So since they don't have the fuel atomization in the intake runner, they're not washing the oil down. There's less time for the fuel air atomization now, since it's being injected directly into the combustion chamber. They're trying to take advantage of higher compression ratios. So now you're having issues with slow speed, pre-ignition, or detonation. Oil has started to have an impact on the burn rates, and because it's going to be in the combustion chamber, so you know, I have 2 sources of fuel in there now. You know, there's a lot of people in diesel world that have actually they would take used motor oil and blend it into their diesel and burn it in those engines. You know, and those engines are starting at about, you know, 16-to-1 compression ratio, and now we're running gasoline engines at, you know, approaching 13-to-1 compression ratio, whether that be static or dynamic, you know, from the artificial aspiration, but we're getting some pretty high cylinder pressures in gas engines. So that's also something to consider. We'll probably have to be more cautious of our choices on, you know, stem seals and their impact on oil consumption. Here's another list of potential issues kind of propagated by oil consumption. And this, again, you know, with direct injection, there's a lot of pictures floating around because of, you know, ports that are almost completely blocked. So you're restricting airflow. If you get too much of the buildup, then it starts to get between the valve face and the valve seat. So you have valve seating issues, plug fouling. You know, we kind of think of that as one of the things from the past, but it gets to a point where it can happen. Again, we're changing our fuel source, so pre-ignition or detonation. Bearing failures and valve guide wear due to lack of lubrication where we expect it to be. So here's just a couple more images. Again, detonation, pre-ignition. You know, for my detonation, I have a secondary unwanted flame front. So, you know, it seems like we've come full circle. Had a industry friend who said, you know, he thought early on that we were working ourselves out of work with our engine designs and so forth. But as of late, that's seeming to be untrue. There's plenty of opportunity, and we're, you know, having to go backwards, like some of the direct injected stuff where they're putting an upstream injector now just to keep the ports clean, and they have a cleaning cycle. So periodically, it'll fire that injector just to wash down the oil in the ports. You see an oil fouled spark plug there, and, you know, a good example, same valve dirty, with buildup and clean. You know, by the shape of that inverted, that kind of Christmas tree shape on the valve, that's definitely entering the combustion chamber by the valve guide and past the seal. I definitely have to say thanks to a lot of our industry friends. And this is in alphabetical order. This is kind of how it falls. But quite honestly, I got a big kudos to a friend at Dana that's been very supportive over the years with information on valve stem seals, Felpro, Molly, member machine shops. I've got a lot of friends out there in machine shops from so many years in the industry, and we get a lot of feedback. Hey, you know, we're seeing this. We get pictures. We get maybe bulletins that they've ran across that we don't have, and so forth. So we really appreciate the feedback from member machine shops. Qualcast, SBI, everybody's help. You know, they help from the standpoint of whether it's pictures, being able to borrow that stuff, or technical information that they share with customers or they develop with. So again, just a big thank you to everybody involved, and let us know what you want to know about in the future. Please. Thank you.
All right, thanks, Chuck. We did have a few questions roll in here for you. The first one was from Joe, and Joe asked, he says, I have noticed a difference in seal lip shape for intake or exhaust applications. Do you have any input into that?
Yeah, exactly. And that's a little bit of the scenario that I was talking about with that Cummins. So on the intake side, often you have either high manifold vacuum, or you have, you know, now there's so many engines that are turbo or supercharged, or whatever, you have boost pressure. So that's kind of what you're trying to compete with was, okay, if I've got boost pressure, then I'm going to want to shove oil back up the guide and allow, you know, blow-by forces to basically end up in the crankcase. So the seal, it may be doing two things. It may be controlling the oil rate that's entering the guide, but is also restricting blow-by pressures from making it, or, you know, boost pressures from making it into the crankcase. And basically the same is true on the exhaust. Usually your exhaust seals are a bit tighter because they're trying to keep pressure from entering the crankcase. You have kind of the atomization effect. I had some illustration on that in the article, you know, because the exhaust is pushing, you know, you got the exhaust valve open, you're pushing the pressure out. And then if you have, you know, the kind of the vortices of the exhaust velocity trying to suck on the exhaust too. So, you know, that's why we got to be careful there. So typically, it's just about, you know, either manifold pressure or vacuum.
All right, the next question came from Pascal, and the question there is how to use a mounting sleeve for correct assembly of a valve stem seal.
Yeah, actually, you know, that used to be much more common because of the shape of the keeper groove. They would, you know, you could buy seals and they would actually package the little clear, like a acrylic sleeve that you would put over the stem of the valve, and then you would press the seal over that so that you didn't potentially tear, scar the valve stem seal lip. Now, that's a very good point to mention. I don't know if we feel that we've improved the materials and the bead shapes in the valves, that's not as important anymore, but that's something that's definitely changed. Years ago, that was something you would look at a lot more closely. Many of the keeper grooves are rotating keeper grooves now. They'll have 2 or 3 beads, and if you ever try, you could put the keepers in the keeper groove and pull the retainer back against it, and like a Chevy, you know, they would lock. They're tight. They don't rotate unless you add a rotating retainer. Well, now with these new designs, the way the beads are actually spaced, they change they lock against the retainer rather than the keeper groove, and then it allows the valve to rotate within the keeper grooves. So it's still a rotator. It's just a whole different method of how to do it. Again, I don't know if that's what's changed these installation sleeves, but I totally I get that. That seems to be something that's kind of gone away.
Okay, I've got a question for you, Chuck. The question goes, can you comment on what percentage of top hat designs would use a case hardened steel to resist wear from the spring?
You know, I could probably investigate that question more. Off the top of my head, that is probably going to be nearly 100%. And the reason I say that is, you know, when valves springs are made and ground on the end, there's always that sharp edge. And as that thing rotates, if it's on anything very soft, cast iron's very self-lubricating and it's forgiving to stuff like that. But if you pick up something like a piece of steel, a soft steel, or the aluminum that's a bit more abrasive, it seems like they dig into that stuff and will tear it up. I've seen actually some that look like they've missed the process before, and it's hammered that steel out. You know, it's amazing how quickly it's worn out. So I would have to believe that nearly all of those are case hardened.
All right, I've got another one here for you. Is it still a good practice with today's technology to use O-ring style seals on the early small block Chevrolet rebuilds?
Absolutely. Even if you choose to put an umbrella, if you choose to put a positive seal on, when you put that O-ring in that groove, that's just more oil that's going to be now deflected by the retainer rather than just allowed to run down and test that seal that much more, you know. So yeah, I think it's good advice. If the groove is there, put the O-ring on it. Otherwise, change to like the vortex style valve and you know, eliminate it completely. That way your retainer, that just make sure everything fits well. So I would advise do it if the groove is there.
Okay, I've got one more here for you, Chuck. Obviously that there's Teflon that's used for crankshaft seals and that sort of thing. Is there Teflon valve stem seals?
Yeah, you know, that's actually something I thought about putting in the presentation and I didn't do it. But yes, the Performance World does some. And then Detroit Diesel on the two-stroke stuff, they actually had a really, really high interference. I mean, it had like 80 thousandths interference on the valve stem. It was a Teflon seal. Once those things were installed, you know, it kind of took a shape. You could like never pull a seal or valve through the seal and then put it back through. I mean, it was just, but yeah, they did make a good number of them many years ago. And like I say, I know people in the performance world that still do that. Even some of the guys that will machine the ID of the guide and put a scarf cut seal on the inside diameter of the guide itself. That way they've got a ton of room for retainer to guide opening. So that's just another kind of a, you know, odd application you're not going to see in day-to-day production, but it is done.
All right. Since we're talking about Teflon seals, here's another question that came in. Fluoroelastomer versus Viton. Is there a difference?
So fluoroelastomer is actually the material, and Viton is a registered trade name. I don't want to speak out of turn, but I think fluoroelastomer, I mean Viton is, that trademark name is actually owned by DuPont. It's like a DuPont product. So, you know, they've got their certain paint lines and so forth. But yeah, Viton's actually a trade name. Fluoroelastomer is the composition. Now, there is some cautions with that. You know, people have some of their own recipes. You can be in a fluoroelastomer classification, then you can start throwing, oh, I think I can make lubricity better if I add some Teflon powders into my fluoroelastomer. Well, you know, that's probably true to a point, but you don't want to get to the point where you've added something, you know, as Teflon or bentonite or something that would make that material take like a compression set, because that seal lip design is supposed to be very dynamic. And if you get the wrong composition, even though it's classified a fluoroelastomer, it may change the seal lip shape, and now you have lost control of oil, you know, oil flow. So probably more than I need to expand on that, but that's just from, you know, seeing it in the past.
All right, here's another one for you, Chuck, that's come in. You showed some. It says, can you purchase that stem seal tester that you had in the slide there, or is that something that's built by a manufacturer?
There's probably both answers are true. Some of the seal design or seal manufacturing companies probably build their own equipment for testing, and there are some companies that manufacture those. There was a company in England, I can't think of the name of it right now, that made a stem seal tester that, you know, you could purchase. And then there's a company called A-House Engineering, A-House Technologies, that they manufacture those. And, you know, so basically a production engine rebuilder, if they did, you know, so choose that they wanted to have that tester, yeah, you can order that machine and you know, probably specify, hey, I want a single cylinder test rig, or I want a 8 or 12 cylinder test rig. And they're probably, you know, pretty flexible in that regard.
All right, Chuck, we got time for one more question. Any of the other questions that have come in, if what we'll do is we'll get back to you. Chuck will make sure to answer any of the remaining ones that are still out there, and then we'll shoot over to Amanda here in a sec. Chuck, the question goes, are there seals made specifically for oversized valve stems?
Yes, but you have to have some volume, and you have to approach a seal manufacturer and tell them what your, you know, your plans are. But the answer to that is yes, they can be purchased. You probably are not going to go through your typical parts catalog and find that. It's something you're going to have to make a phone call. That's like many of the oversized OD main and rod bearings that maybe a manufacturer has. You know, sometimes you just have to pick up the phone call or phone because they have chosen not to put that in the catalog or something.
All right.
Well, thanks, Chuck.
Thank you.
We want to thank everyone for your time today. And I just want to let you know, you will get a follow-up email tomorrow, and that email will contain a link to today's webinar. So you can rewatch it, you can share it with staff, friends, whatever you want. That's yours to do with as you wish. Also, when you exit the webinar today, there will be a survey that pops up. Please take a moment and fill out that survey. Just lets us know how we're doing and what you want to see. And then lastly, you will see our contact information is there. That 815-526-7600 will get you to the main line at AERA, where you can reach anyone on our team. And then my email address, Chuck's and Rob's, are listed there, as well as Karen, who handles our membership. Thank you again, everybody. And any of the outstanding questions, as Rob said, we will get answers to you yet this afternoon. So have a great rest of your day, and we appreciate you joining us.